Algebra 2, it's Mr. Szybisty. We're going to talk about Unit A1, which is Permutations and Combinations. So just a reminder of what you're going to do. I'm going to go through about 4 problems with you today that talk about this concept, Unit A1, which is Permutations and Combinations. And what I want you to do is take notes just like you would in a regular math class. However, you can pause it, rewind it. Anytime something that I say and you need an extra second, go ahead and pause the video so that you can write down what you need. We're going to jump right in with an example. And in this example, there are students who are going to receive a prize. There are 3 students, Julie, Kendall, and Bill. And there are 2 prizes that they could win, $50 and $5. Here's the question. How many different ways could these 3 students be placed into these 2 prizes? Let's figure it out. Well, one way that it could work is Julie could get $50 and Kendall could get $5. There's one way. Well, another way would be if Julie still got the $50 and Bill got the $5. That's way number 2. Another way might be, well, let's say Kendall got the $50 and Bill got $5. So there's 3. I think there's still some more. Well, Bill could get $50 and Kendall could get $5. That's way number 4. Another way, Bill could get $50 and let's say maybe Julie would get $5. There's one more missing. Pause the video right now and see if you can't figure out which combination here is missing. The last combination that we haven't seen yet is if Kendall gets the $50 and Julie gets $5. If you're able to find that, give yourself a round of applause. You'll notice in this problem, we call this a permutation. The reason we call it a permutation is because, and this is important, so you want to write it down, order matters. In this circle, you have Julie and Kendall. And in this circle, you have Julie and Kendall. But they're different because here Julie got $50, and down here Kendall got the $50. They're different. So the order in which they got placed matters. We call that order matters. And when we do, it's called a permutation. There were 3 possibilities, 3 students, and there were 2 prizes. So here's the way that we're going to write this using math. Because it's a permutation, we'll use a P. There were 3 people to pick from, and we picked 2. So that is one way that we can write this permutation. That there were 3 possibilities, and we're going to pick 2 of them. Let's see another one. So here we are with the next example. So this is example 2 out of 4. In this example, we're curious about some cross-country runners. We've got 10 cross-country runners on our team. Ben, Nolan, Emily, Blakeney, and Sam, Brandon, Chris, Nate, Hannah, and Wade. And they're all running a cross-country race, and I'm curious, how many different ways could they finish first, second, or third? Well, let's go back and let's see if we could start figuring this out. Well, you could finish Ben first and Nolan second and Emily third. That would be one. Or Nolan first and Ben second and Sam third. There's a lot of different ones we'd have to go through. That's just 2 of a bunch. So I think this is another case where order matters. If Ben comes in first, that's different from this one, where Nolan came in first. So the order that they finish really doesn't matter. So I know that this again will be a permutation because order matters. Now, thinking back to our last one, I know I'm going to use a big P because it's a permutation. I got 10 possibilities, and I'm going to pick 3 of them. So I have 10 possibilities, and I'm going to pick 3. And we're going to leave our answer like that. That's a way that we can express the number of ways that these 10 cross-country runners will finish first, second, and third. Now, in class, the next period, we're going to talk about how do you actually find that number. And there's a formula. You can also use a calculator for that. We'll talk about that next class period. But for right now, all you need to do is write that. And if we can write that, we've analyzed this situation properly. Now it's time for a third one. All right, it's time for example 3 out of 4. I've got a group of people here. There's Kyle, Monique, Danielle, Heidi, and Tanya. And out of this group of people, I want to pick a committee of 3, which means out of the 5, I'm going to take 3 of them and put them on a committee. So let's see some of the possibilities. Well, one committee could be Kyle and Monique and Danielle. That would work for one of them. Another one that might work would be Danielle and Heidi and Tanya. There's a second one. The question that we get here, Kyle, Monique, and Danielle, that was one of our possibilities. Is that the same thing as Monique, Danielle, Kyle? Are these 2 the same? Now, because there's no ordering, they're just sort of a group of individuals. There's nothing that changes their placement. In this case, order doesn't matter. These are the exact same. It doesn't matter how you put them into the committee. The committee of 3, a committee of Kyle, Monique, and Danielle, is the same as a committee of Monique, Danielle, and Kyle. It's not like the cross-country when they were finishing, or the students in our first example that were awarded specific prizes. So these are the same. When order does not matter, we call that a combination. And instead of using a big P, we're going to use a big C to talk about the different possibilities. The numbers that we put next to this are the same as with the permutation. There were 5 possibilities. We're picking 3. Next class period, I'm going to show you how to use the calculator and a formula to figure out what that number is. But for right now, because the order does not matter, it's a combination. We're taking 5, and we're finding 3. We're finding, in this case, committees of 3. So that is going to be our answer for right now. All right, our last example, our 4th one today, is this real-world one. A sample of 3 fuses are picked from a box of 500. How many different groups of 3 fuses can be picked? So let's get an idea of what's going on here. There's this box out there that has fuses in it. And we're going to reach into this box and grab a handful of 3. We're going to pull them out. And the question is, how many different groups of 3 could I pull out? Well, it doesn't matter the order. It's not like I'm pulling out 1, then a second, and then the third. So this is another case of order doesn't matter. So this is a combination. So I know for my answer, I'm going to use a big C because the order doesn't matter. Now, how many am I picking from? 500. And I'm choosing 3 of them. And so that's my answer. Out of the 500 I'm reaching in, I'm only pulling out 3. And so for right now, we're going to leave that as the answer. And as long as you can write this, you've analyzed the problem well enough that you'll be able to do very well on a test or on the SOL at the end of the year. Make sure that you have gone back, rewind, rewatch, pause at the parts that you need to, and at this point you're going to complete your summary, write 5 sentences detailing what you saw in this video, and then make sure you also write your 2 questions, one that you want to have answered, and then another one that you think that someone else in the class might have that same question, but you can answer. Thanks for watching. I can't wait to talk about this with you guys in class.